Hello friends, let us see what are Boolean functions. A Boolean function can be represented by f, which is a function of variables a, b, c, d and so on up to z. Okay, this function may have some terms, product terms, okay. Suppose take an example that f of a, b, c is equals to a plus bc plus b a plus c. This is an example of Boolean function. And why it is called Boolean function? Because its value will either be 1 or 0. Okay, it may be 1 or it may be 0 depending on the values of these variables. This one, this one, this one, this one, this one, this one. Okay, that is depending on the values of these three variables a, b, c. The function may have either a 1 or 0 at the output. Now, these Boolean functions can be of three types. First one is that is SOAP form. SOAP stands for sum of products. Okay. Second can be POS form. That is product of sum. Okay. And the third can be a canonical form. That is canonical form. Let us see what is sum of product form. Sum of products or SOAP. In sum of products form, it is represented, that is a function, Boolean function is represented by sum of product terms. Here a, b plus b, c plus a, b, c. These are product terms. Okay. These are product terms. And we are adding these terms. That is taking the sum. Okay, that's why it is known as sum of product terms. Or you can say that sum of product form. Second form is your product of sum. That is POS form. In case of POS form, Boolean function is represented in terms of product of some terms. That is, see here as like here, if f a b c is a Boolean function, then a plus b is a sum term which is multiplied with either a plus c plus b or a plus c or anything else. So these are actually your sum terms. Okay, these are sum terms. And here we are doing the product of these sum. That's why this is known as your pos form. Now the third is, that is, canonical form. Now before discussing canonical form, look at these two functions first, that is your sum of product form and your product of sum form. See here, the first term of SOAP form contains only two variables, second form contains only two variables, third term contains all the three variables of this function a, b, c. And in other words, you can say that in first term, this is your first term, okay, first term c is missing, whereas in second term a is missing, either a inverted a or simple a. Okay, in third all the three terms are present. That's why it is a SOAP form but not a canonical form. Similarly, in pos form, you can see here in first term c is missing, c or c bar is missing. In third term b or b bar is missing, whereas in second term all the three variables are present. So a canonical form is that form, either a SOAP canonical form or a pos canonical form. Okay, this may be either SOAP canonical or it may be pos canonical. That is pos canonical. Now how we can convert this SOAP form in SOAP canonical form? Again consider the same example, that is this one. Suppose we want to convert this function a, b, c of SOAP form into canonical form. Then we have to move like further. We have to move like this. That here look at the first term, which variable is missing? C. Okay, so we have to use Boolean theorems and multiply it by c plus c dash, because c plus c dash or c bar results in a 1. Similarly, in second term a is missing, so we can multiply a plus a bar with bc plus abc. So if we use distributive law, then it becomes abc. This becomes abc bar. Here it becomes abc plus a bar bc plus ABC. You can see here that this ABC and this ABC can be combined using Boolean theorem. So you can write single ABC plus ABC bar plus A bar BC, and this is nothing but this is your SOAP canonical form. Now each term of this SOAP canonical form is known as mean term of the function. Okay, please be remember this mean term is represented by a small m. Okay, so all these three terms are actually the mean terms of your given function f a b c. Now consider again the conversion of POS form to POS canonical form. Okay, consider the same function here again, that is a plus b. F is a function of a b c, where a plus b plus a plus b plus c plus a plus c, a plus c. In first term c is missing, so we can write a plus b plus c bar using the Boolean theorem, because c dot c bar is equals to 0, so it will not affect it. So a plus b plus c multiply a plus b bar dot b plus c. Okay, again using the another Boolean theorem, that is using this, that is if a plus b bar is there, you can write it like this: a plus b multiply a plus b bar. So we can expand this term and this term, that is a plus b plus c multiply a plus b plus c bar multiply a plus b plus c multiply a plus b plus c multiply a plus b bar plus c. Combining the similar terms are here this one, this one and this one. So you can write it as a plus b plus c multiply a plus b plus c bar multiply a plus b bar plus c, and this results in your POS canonical form. Note that each term of this POS canonical form is known as max term. Okay, and max term is denoted by capital M. Okay, remember this thing always.